Good afternoon. My name is Jared Keller. We have Owen, Finley, and then Luke. And together we're presenting to you the parking management system. Now, that's pretty self-explanatory, but let me break down the problem for you a little bit. Now, I know everybody here hates traffic. I know that I hate traffic. And anybody that has been here at UTD for longer than a few years has seen that the traffic situation has improved, but it was definitely a little worse back a few years ago. So that's what inspired the project overall. Now, when we looked a little bit more into it, IBM has a little study that says that a large chunk of traffic is actually caused by people in inefficient parking scenarios where they can't find a parking space, etc., and that causes a lot of traffic. So we wanted to fix that problem. And we were going to fix that with the objectives here, which is space availability recognition. Essentially, when a car parks in space, we want to be able to relay that information to the user as well as administrators, how many available parking spaces there are. Also, parking violation recognition. We want to be able to automatically determine whenever a car is parked in a spot that should not be parked in, and then flag that as a violation to the administrator so they can enforce it. Now, it is semi-autonomous. This is to alleviate the need for parking enforcement personnel and employees in general. Anybody that's familiar with the UTD system, they have a large team of enforcers that walk around generally aimlessly in the lot, and sometimes they're successful, sometimes they aren't. This will fix that problem and flag the appropriate lots for enforcement. Adaptability. Now, we want to be able to implement it anywhere, indoor, outdoor, and while we haven't gotten around to testing actual outdoor behavior yet, the indoor works just fine. And we wanted to be able to use it for, no gates or gates, either way. And also, last but not least, cheap implementation. We wanted to be able to make this parking enforcement scenario without spending a whole bunch of money, like, for instance, a rotating camera. Now, system solutions. It's three parts, three primary parts. One is the RFID reader, which scans registered tags. They're pre-registered, and it has a, for instance, gold, green, tier 1, tier 2, unique to each tag. So as they pass by the reader, that then communicates with the Wi-Fi capable Arduino Megas, which are hooked up to sonar sensors. Now, all together, they work and they send the data to a web page that we developed, and to display all that information and how they interact with each other. Now, we believe this implementation will save productivity and just general time waste. Now, if you look down here at the bottom of the diagram, just kind of go through the flow of it. Now, a car would go into the parking lot. The RFID reader would detect the tag. Then it would detect the tag, and that would indicate that a car is inside the lot, which keeps that information. Moving along, as it parks into a parking spot, one of these two Arduinos, or it can be up to 10, for instance, if you have a large lot. They're hooked up to the sonar sensors, and as a car parks in the spot, the sonar will know that or recognize that a car is there, and that will then compare that data to the RFID to determine if it should be parked there or not, and it sends that data with a Wi-Fi chip to the website. You can see that. And now I can open it up to any questions.
How do you visually show that the parking spots are taken?
It's a simple HTML table. It just keeps track of how many spaces are available, and it just updates that about every minute or so. And it's just in a simple table. It has, you can separate it into different space tiers like green, gold, or if it's a number system, 1, 2, and then it'll show how many available spots those are. And you can separate those tables into separate lots as well if you have a large network going on.
Is the RFID reader at the entrance of the
yes, I'm sorry, I wasn't very clear about that. Yes, it's at each entrance and exit. There has to be at least one on each entrance and exit, so it can register when cars come in and out of the lot, and it can compare that with the sensor so it can properly flag any violations.
And how do you know if they're in the right spot then? Like if I come in with a green tag, obviously you can tell, okay, this is a green tag from the RFID reader, but you're just using sonar at the spot. How do you know?
Each sonar, the sonars, they are set up to where certain sonars are green and certain are gold. And whenever the RFID data and the sonar data mismatches, it'll flag that as a potential violation for somebody to go check it.
Well, then if the sonars are green and some are gold, explain that.
Yeah.
Well, they're just handled differently in the software. So, for instance, all of the sensors on the master board, because there's one master board and the RFID and the associated Arduino Megas, those are all the slave devices, so it all works off of one. We separated it into, for instance, the green code was on, or the green sensors were on the master device, and the gold sensors were on the slave device, and we were able to just kind of differentiate between those. Whenever the data mismatched, that's when we put up a flag.
I'm still having trouble understanding the match here. You're assuming one car is driving and then parking in the lot at a time. How do you know that the green car would?
Well, as for instance, say a green car goes into an entrance, it will send that one green car is entered to the Arduino. And whenever that car parks in a spot, say it parks in a gold spot instead of a green spot, it's not going to, the data is not going to match. Like it knows how many green cars are inside, it knows how many gold cars are inside. So if those associated spots are not occupied and the numbers don't match, then it throws up a violation for somebody to then go there in person.
It's just counting the number of green cars that enters the number of spots? So
yeah.
it doesn't necessarily record which of the spots.
Yeah, which is why it's not fully automatic.
Okay.
This is the last question. The radars have an ID, or do you know what?
Yeah, each tag is unique, and you can put, we actually didn't even use all the data, we can put additional data on it, but right now we have it set to where the tags that we have, you have to register them, so the tags are unique, some of them are gold, some of them are green, so as they go in, it'll keep track of how many greens are inside and how many golds are outside, inside, and then when they exit, it'll remove them, so it'll keep track of how many of each tier is inside and how many tiered sonar sensors and if they match or not.
All right.